Hello friends, today I will discuss the derivation for rotating magnetic field in the three-phase induction motor. There are three conditions to get the rotating magnetic field in the stator of the three-phase induction motor. First condition is the windings placed on the stationary should have the phase angle between them 120 degrees. The second condition is the applied voltage three-phase AC supply should be balanced. That is, their phase voltages should be 120 degrees apart from each other. And here the assumed phase sequence is RYB. This means phase sequence RYB means phase R will reach its maximum first, then phase Y, then phase B reaches their maximum. The stator of the three-phase induction is connected in the star form or in the delta form. Then the input voltage is three-phase AC and the induced fluxes by the currents are given by like this: phi R, phi Y, phi B. Phi R belongs to the flux produced by the phase R. Phi Y represents the flux produced by Y phase. Phi B means it is the flux produced by phase B. If it is observed that phase R, phase Y have the phase angle of 120 degrees. Similarly, between Y and B, the phase angle is 120 degrees. Similarly, from we can say here the maximum value of all the phase value is phi m. Similarly, there is a minus phi m also. There is a zero value here and there, and here at 0 degrees means this is the 0 position, this is 1 position, this is 2 position. 0 theta is equal to 0. This is the x-axis means theta. When theta is 0, phi r value is 0, whereas phi b has the positive value. That value is 0.866 phi m, and whereas phi y also have the value but negative value, that is here, that is minus 0.866 phi m. To get these values, in the analysis, these figures will be covered. Similarly, at theta is equal to 60 degrees, position 1 means it is theta is equal to 60 degrees. At 60 degrees, Y phase value B phase value is 0. B phase flux is 0, whereas phi r value is positive, and that value is given by 0.866 phi m, whereas phi m is also phi y is also there, but its value is minus 0.866 phi m. Similarly, when theta is equal to 120 degrees, that is at position 2, the theta value is 120 degrees. In that case, phi y value becomes 0 because this is phi y waveform, it is 0, whereas phi r is positive, whereas phi b is negative. This is phi b, this is negative, phi r is positive. So phi r is equal to 0.866 phi m, whereas phi b is equal to minus 0.866 phi m, and phi y is equal to 0. So having known this, we can also observe the phase displacement between the fluxes phi r, phi y, phi b like this. So they are 120 degrees apart with respect to each other. This is phi r, this is phi y, this is phi b. So each vectors with the neighboring vector displaced by 120 degrees means this indicates the applied voltage is balanced. So let us see general equation for phi r. Phi r is nothing but phi m sin omega t. So omega t we replace with theta. Similarly phi y we write phi m sin omega t minus 120 degrees, that is phi m is equal to, sorry, phi m into sin theta minus 120. Similarly phi b is phi m sin omega t minus 240 degrees. From that we can write phi m sin theta minus 240 degrees. So these are the general equations. At theta is equal 0, find out what is phi r. Similarly when theta is equal 0, what is phi y value. Similarly when theta is equal 0, what is phi b value. Mean having known phi r, phi y, phi b, then the total flux or resultant flux can be calculated by adding all phi r, phi y, phi b vectorially. So let us see each case. When theta is equal to 0, look at the formula here. Phi r is equal to phi m, theta is equal to 0 means sin 0 means 0. Phi r becomes 0. That's what is written here. Similarly phi y is equal to phi m sin theta minus 120. Theta is equal to 0, so 0 minus 120 degrees. So then we get minus 0.866 phi m, which is already shown with the diagram, with phasor diagram. Similarly, what is phi b? Phi b is nothing but phi m sin theta minus 240 degrees. Theta is 0, so we get here minus 240 degrees. Simplification leads to 0.866 phi m. Phi r is 0, phi y is this, phi b is this. And we have seen, so phi r means this is the positive direction of flux phi r. This is the phi b means this is the positive direction of phi b. And negative means it will become in the negative direction. Similarly phi r negative means it will come like this. Similarly phi y means this is the positive direction of phi y. Negative direction means this side it will come. So having known this, so it is possible to draw this vectors phi r, phi y, phi b when theta is equal 0 degrees like this. One is phi b, the other is phi y. So phi b is 0.866 phi m, whereas phi y is minus 0.866 phi m. So constructing the parallelogram with these vectors OB and OC, then we get vector like this, that is total flux representation. So draw a perpendicular line from this point B to this diagonal, that is at point D. BD becomes perpendicular to the OA. So this is nothing but AO is nothing but DA and DO, means both are equal, means this line BD intersects, bisects this total flux. That is total flux can be calculated 2 into OD or 2 into AD. So from the vector diagram it is observed that cos theta is nothing but cos 30 is equal to OD by dV. And we know what is phi t. Phi t is nothing but 2 into OD times, and OD is nothing but OB into cos 30 from this equation. So we write 2 into OB cos theta, And what is OB? OB is also known, that is nothing but 0.866 phi m into cos theta. Here theta is 30 degrees. Then the equation becomes total flux becomes 1.5 times maximum flux with vertical line. The position of the resultant flux is in the upward direction, heading towards right clockwise direction. Similarly, when theta is equal to 60 degrees, the similar equations we can write what is phi r, what is phi y, what is phi b. So it can be observed that when theta is equal to 60 means at position 1, then the phi b is 0, whereas other values are present. Phi y is minus, phi r is plus. So look at this, phi r is equal to phi m sine 60 is equal to 0.866 phi m. Similarly, phi y, phi m sine minus 60, then we get like this minus 8.66 phi. Then phi y will become phi m sine minus 60 degrees, that is minus 0.866 phi m. So all these values are coming based on the first fundamental equations. Phi r is equal to phi m sine theta. Similarly, phi y means phi m sine theta minus 120 degrees. Phi b means it is phi m sine theta minus 240 degrees. So replacing theta value like this 60 degrees, then phi r becomes 0.8665 m, phi y becomes minus 0.866 m, and whereas phi b becomes 0. And then drawing the vector diagram for this, so positive direction means phi r direction in the original vector diagram, and here also same, whereas phi y positive direction assumed is different, and here we are getting negative. So opposite to the positive direction of the y phase will lead to minus. This is minus side, that is OB. So phi y will become minus 0.866 phi m, and phi r is already there 0.866 phi m. And taking this parallelogram and then finding the phi t is nothing but 2 into OD, then that becomes 1.5 times maximum flux. Similarly, when theta is equal to 120 degrees, so again we use same equations. Phi r is equal to phi m sine omega sine theta, and phi y is nothing but phi m sine theta minus 120 degrees, and then phi b is equal to phi m sine theta minus 240 degrees. So using those equations, phi r is equal to phi m sine theta. In place of sine theta, because theta is assumed at 128 degrees, then we get here 0.866 phi m. Similarly, phi y is 0 at 0.2. Similarly, and there is a value for the phi b, that is nothing but phi m sine minus 60 degrees, that is minus 0.866 phi m. And having known these values and positive direction of phi r, negative direction of phi r, positive direction of phi, and negative direction of phi, and phi b, positive direction and negative direction, the vector diagram can be written like this. Phi b is with a negative direction, negative value. This is the positive value of the positive direction of the phi b, whereas this is the negative direction of phi b. So phi r is anyhow positive, and then calculate the parallelogram, then find out what is the total flux from here to here, that is nothing but 2 into OD times, and here is 30 degrees. So then we get phi t is equal to phi r phi b plus 0 will give us 1.5 times maximum flux. And it can be observed that When theta is 0, the resultant flux is here rotating at synchronous speed. So when theta is equal to 60 degrees, then the resultant flux will be like this. Earlier it was here, then now it is here. Means moving the resultant flux from left to right, that is in the clockwise direction. So here also maximum flux or total flux is nothing but 2 into OD times. So that results in 1.5 phi m. Similarly, case 3, when theta is equal to 120 degrees, means position is 2. Position 2 is nothing but 120 degrees, and if it is observed that phi y value is 0, whereas phi b is negative and phi r is positive. So phi r is equal to 0.866 phi m, and phi y is 0, that is phi m sine 0, then phi b is equal to phi m sine minus 60 degrees, then we'll get here minus 0.866 phi m. And this is the negative direction of the phi b, this is the positive direction of phi b, and this is the positive direction of phi r. So then the resultant of phi r and phi b is nothing but phi t, and that phi t is nothing but 2 times OD, and after simplification the total flux results in phi t is equal to 1.5 total flux, maximum flux. In summary, we can say when theta is equal to 0, the resultant flux is here, that is when the vertical position, and when theta is 60 degrees, it moved from vertical position to the clockwise direction like this here, and then when theta is equal to 120 degrees, then the resultant flux further rotated in the clockwise direction like this. So means the flux is rotating from this position to this position, from this position to this position, that is in the clockwise direction, and its speed is synchronous speed, that is ns is equal to 120 f by p.